How large is our solar system, the galaxy, and the universe? Have you ever looked up into the sky and wondered what was there? Higher than the birds, past the clouds, and farther than the moon, a whole host of fascinating objects spin in outer space. From the sun to how big is our solar system, let us go for a ride across the solar system and learn about it. The solar system, either directly or indirectly, is the sun's gravitationally bound system and the objects that orbit it. Of the objects directly orbiting the sun, the 8 planets are the largest, with the remaining being smaller objects, dwarf planets, and small bodies of the solar system. Among the objects which indirectly orbit the sun, the natural satellites, 2 are larger than Mercury, the smallest planet. Welcome to Brainbender Solarium, as we travel through space and look at the expanse of our solar system. $4.6 billion years ago, the solar system was formed from the gravitational collapse of a giant molecular interstellar cloud. The vast majority of the mass of the system is the Sun, with Jupiter containing the majority of the remaining mass. Earth, Mercury, Venus, and Mars, the 4 smaller inner planets, are terrestrial planets composed primarily of rock and metal. The 4 outer planets are giant planets, much more huge than terrestrial planets. Gas giants that consist primarily of hydrogen and helium are the 2 largest planets, Jupiter and Saturn, while the 2 outermost planets, Uranus and Neptune, are ice giants that comprise mostly of substances with comparatively high melting points compared to hydrogen and helium, known as volatiles, such as ammonia, water, and methane. There are almost circular orbits on all 8 planets that lie inside an almost flat disk called the ecliptic. Smaller objects are also found in the solar system. Located between the orbits of Mars and Jupiter, the asteroid belt mainly includes objects consisting of rock and metal such as terrestrial planets. The Kuiper belt and scattered disk, which are populations of trans-Neptunian objects consisting primarily of ice, lie beyond Neptune's orbit, and beyond them a newly discovered population of sednoids. There are objects large enough to have rounded under their own gravity within these populations, but there is considerable controversy as to how many there may prove to be. Objects of this type are known as dwarf planets. The only certain dwarf planet is Pluto, which is supposed to have another trans-Neptunian object, Eris, and the asteroid Ceres, which is at least similar to a dwarf planet. In addition to these 2 regions, numerous other small body populations openly migrate between regions that include centaurs, comets, and interplanetary dust clouds. 6 of the planets, 6 of the largest dwarf planets possible, and numerous of the smaller bodies are orbited by natural satellites, usually referred to as moons, after the moon. Planetary rings of dust and other tiny objects encircle each of the outer planets. In the interstellar medium known as the heliosphere, the solar wind, a stream of charged particles flowing outwards from the sun, creates a bubble-like area. Heliopause is the point at which the solar wind pressure is equal to the interstellar medium's opposing pressure. It stretches to the edge of the scattered disk. The cloud of Oort, which is known to be the source of long-period comets, may also be about 1,000 times more distant than the heliosphere. In the Orion Arm, 26,000 light-years from the center of the Milky Way galaxy, the solar system is located. Let us talk about the far-reaching solar system. In the extreme reaches of the solar system, scientists have spotted a distant planet that orbits well beyond Pluto. The object, informally known as L91, could be in the process of gradually moving its way inward from the Oort cloud into the surrounding, similarly icy Kuiper belt, a repository of comets and other icy bodies. No object was ever seen doing so. The L91 orbit has revealed more about the extreme worlds whose orbits lie outside the gravitational reach of Neptune, which is the most distant giant planet in the solar system. How these bodies end up in their present orbits has yet to be thoroughly described by researchers. According to Meg Schwamb, a planetary scientist at the Gemini Observatory in Hilo, Hawaii, says that it adds another piece to the puzzle every time we find another one of these objects. In September 2013, using the Canada-France-Hawaii telescope in Hawaii, astronomers with the Outer Solar System Origin Survey discovered L91's orbit. A detailed survey of a small part of the sky was undertaken by the party, attempting to catalog and identify the Kuiper belt objects within it. What object is found in the extreme reaches of the solar system? The elliptical orbit of L91 never takes it closer to Earth than about 50 times the distance from Earth to Sun, or 50 astronomical units AU. The object is 1,430 AU away at its furthest point. That means that its orbit is more extended and centered farther from the Sun than worlds such as Sedna and 2012 VP113 have previously been discovered. Michael Bannister, an astronomer at Queen's University, Belfast, UK, said that the location and trajectory of L91 makes it fascinating. On the 17th of October, at a joint meeting of the Division for Planetary Sciences at the American Astronomical Society and the European Planetary Science Congress, she announced the discovery. By gravitational encounters with Neptune in the distant past, L91 could have been thrown into its remote orbit. Nathan Kaib, an astronomer at the University of Oklahoma in Norman, says that this one is right on the hairy edge of everything. Bannister and her colleagues suggest that the object could have been banished from the Sun as far as 2000 AU until it started to ease its way back into the gravitational pull of the star. She said that the orbit of L91 is changing in quite a remarkable way. However, Konstantin Batygin, an astronomer at Pasadena's California Institute of Technology, is not so sure. He believes the suggestion by Bannister that L91 was first tossed towards the cloud of Oort and is now heading inward is too complicated. He suggests that an unspecified giant planet such as Planet 9, which he and a colleague suggested in January, could more simply and explicitly shepherd L91's orbit instead. Instead of being rotated at high angles, Bannister counters that object L91 travels an orbit that is almost within the plane of the solar system, as might be predicted if it were being knocked around by Planet 9. So, how big is the solar system? Our solar system is so massive that if you use ordinary units like feet or miles, it is almost difficult to imagine its size. The distance from Earth to Sun is 149 million kilometers, 93 million miles. But the distance from Neptune to the farthest planet is nearly 3 billion miles, or 4.5 billion kilometers. When comparing this to the distance you can walk in one full day, i.e. 70 miles, or fly in 24 hours from the International Space Station, that is 400,000 miles. The best way to understand the size of our solar system is to build a model of it that reveals how far the 8 planets are located from the Sun. Astronomers use the distance of 93 million miles between Earth and the Sun as a new unit of scale called the astronomical unit. For the Earth-Sun orbit distance, it is specified to be exactly 1.0, and we call this distance 1 AU. So what actually is the diameter of the solar system? It's a matter of perspective and characterization to determine the solar system's diameter. The diameter of the solar system can be looked at as ending at the aphelion of the farthest planet's orbit and the edge of the heliosphere, or as ending at the farthest visible object. We will look at all three to cover all of the objective bases. The solar system will have a radius of 4,545 billion kilometers and a diameter of 9.09 billion kilometers, looking at the aphelion, according to NASA figures, of the orbit of the most distant known planet Neptune. This diameter could change if, after further research, the dwarf planet Eris is promoted. 3 times more distant from Earth than Pluto is Sedna, making it the most distant visible object in the solar system known. It is 143.73 billion kilometers from the Sun, thus giving a diameter of 287.46 billion kilometers to the solar system. Now that's a lot of zeros, so let's simplify them into units of astronomy. 1 AU, or Earth to Sun distance, is approximately equivalent to 150 million kilometers. Sedna is approximately 960 AU from the Sun, and based on that calculation, the diameter of the solar system is 1,921 AU. A third way to look at the solar system's diameter is to say that it stops at the heliosphere's edge. The heliosphere is also defined as a bubble in which the solar wind pushes against the interstellar medium, and the edge where the gravitational forces of the Sun are stronger than those of the other stars. Heliopause is the word that is given as the edge of the strength where the solar wind is stopped and our Sun's gravitational force fades. That occurs at about 90 AU, giving a diameter of 180 AU to the solar system. If the effect of the Sun stops here, then you may wonder how Sedna might be considered part of the solar system. Although at aphelion, it is outside the heliopause, so it falls back into it at perihelion around 76 AU. Such solar system diameter determinations may seem about as plain as mud. but they give you an idea of what scientists are trying to put a definitive value on. The distances involved are mind-boggling, and it's hard to boil it down to an absolute number considering there are so many unknowns. As the Voyager probes continue their outward journey, perhaps an exact number would be determinable.